this is workshop 4, video talk through part 2. So we are starting from step 4. So in other words, we have looked at our time series and we have checked to make sense and looked at what we expect the Nyquist frequency and our frequency resolution to be. So now we need to convert to the frequency domain using the fast Fourier transform technique. So look at step 4 down here. Use the function that was generated in workshop 3. So I've actually provided these for you again because I think I've tidied them up a little bit, so they look a little bit different from what we generated in workshop 3, but they're basically the same commands, just with a few more comments and things. Okay, so let's just open up that function. Okay, so what I have added to it are these comments which explain what the input and output are. So generally when you have a function, it's quite useful from the point of view of being able to know how to use it in the future if you define what are those variables that are inputs and what are the variables that are outputs. Okay, and anything else is defined internally within the function itself. So what we want to do then is put this new carbon dioxide time series into this function and generate frequency and power spectrum. Okay, so we'll do that from the command line down here. So let's type in, actually, let's generate a new script, because what we'll do is we'll probably plot it in the end anyway. So let's call it, what should we call it? Plot PSD CO2.m. Okay, and then we'll say, put a little comment in about what we're doing. Plot PSD for CO2 data using FFT method. There. But we need to, before we plot it, we want to generate the power spectrum. Okay, so we're going to call our find PSD FFT function. So frequency PSD Y and the function find PSD FFT. As inputs, just to check we've got them in the right. Yeah, frequency PSD Y, and then we want Y comma dt. Okay, so we have actually got a time series called Y, and we don't have dt yet. So what we'll do in a moment, we can define dt up here. So dt is 1. Okay, in months. So 1 sample per month. Okay, so now we've got the power spectral density. We need to plot it. So to plot it, I don't think I gave you a function for that, did we? No. Okay, so what we want to do then is plot frequency, comma, 10 times log base 10, log 10 of PSDY, and let's put this in a figure, figure 2. Put some labels on the axes. X label is frequency, in 1 per month. I've got enough brackets in there. Okay, Y label is power per unit frequency. Okay, that typo. And then we can put a title if we want, which is PSD of raw CO2 data using FFT method. Okay, so let's save that as, oh, we'll use the same title that we put at the top, plot PSD CO2, save, and let's run that. Oh, this is my old figure, so I should just delete that. Okay, run that again. There. Okay, now you'll see that when we look at the command window, you can see that there is a warning sign. It says integer operands are required for colon operator when used as an index. So the problem that we're running into here is that in find PSDFFT, if I go to that function, you'll see that at some point here we're defining intervals based on n divided by 2, and n in our case here, we type in n is the length of the time series, so n equals length of y is 161. So that means that we're getting a fraction here, which MATLAB's not particularly happy with because you can't have an index of an array which is a fraction. So it needs to be a whole number, and in order to make this into a whole number here, it means that the length of our time series should be even. So what I'm going to do, rather than calling this function and inputting the whole time series, I'm just going to knock off the last data point. So I'm going to call that function from the first data point to the last -1. Okay, so save that. Whenever I run that again, then you can see down here in the command window that we don't get an error. Okay, so this is the figure that we should generate, and you can put a grid on it. So in step 6, it says change the axis on the X-plot to represent frequency in 1 per year, and add a grid. Okay, so we want to change it to frequency in 1 per year. We've got 12 months in a year, so multiply that frequency by 12, and then we could put grid on, save that, run it again, and then we get the same figure that we have in the worksheet instructions.